Hello students, in this lecture we will study about refraction through glass slab. Okay, so let's see, there is a glass slab and thickness of this glass slab is T. Okay, T is a thickness of glass slab. Now this outer medium is a air. So let's say this is our rarer medium. So refractive index of rarer medium is 1. I am taking rare medium as air and denser medium is glass. Okay, so refractive index, let's say refractive index of glass is mu. So this glass is my denser medium and rarer medium is air. Okay, so now let's place a object. So this is a object O. Okay, and name the surface of a slab. This surface is PQ and this surface is RS. Okay, now let's first take refraction refraction from refraction from surface. Okay, refraction from surface PQ. Okay, refraction from surface PQ. So in this case what happens, the light ray from the object falls on the surface PQ like this. Okay, now this is my incident ray. So because incident ray is in a rarer medium, incident ray is in a rarer medium, so we consider that the object is in a rarer medium. Now when the object is in a rarer medium, the formula of apparent depth is apparent depth divided by real depth is equal to refractive index of denser medium divided by refractive index of rarer medium. So this formula we will apply it. Okay, so this is a formula of apparent depth when the object is in a rarer medium. Okay, now let us consider this distance is x. So this is a real depth. Okay, now let's say d1 is a d1 is a apparent depth in this case. D1 is a apparent depth. Okay, now apply this formula. So apparent depth is D1. So D1 divided by X is equal to refractive index of denser medium is mu. Mu divided by 1. So from here you will get D1 is equal to mu X. Okay. So D1 is equal to mu X is a apparent depth from this surface PQ. Okay. So let's draw the ray diagram also. So outside is a rarer medium and this is a denser medium. So when the light ray goes from rarer medium to denser medium, it bends towards the normal. Okay, so it bends towards the normal like this. Okay, it bends towards the normal. So for the surface PQ, this red color line is a refracted ray. So when I extend it in a backward direction like this, when I extend this red line in a backward direction, I will get the image. This is the image formed by surface PQ. So this is I1. Now the distance of this I1 from the surface PQ is how much? D1. D1. That D1 is equal to mu x. Okay. So this is the image formed by the surface PQ. Now let's see this surface RS. Okay. Now refraction from refraction refraction from RS. Okay, now to see the refraction from RS. So in case of a RS, this red line is my incident ray. So this incident ray is in a denser medium. Now because this incident ray is in a denser medium, I consider that the object is in a denser medium. Now when the object is in a denser medium, the formula for the apparent depth is dA divided by dr is equal to mu r divided by mu d. So this is the formula for apparent depth when the object is in a denser medium. Okay, why I'm considering here that the object is in a denser medium, because this red line, which is a incident ray for the surface RS, is in a denser medium. Okay, now what is the real depth? Now real depth is a distance, this distance here to here. Okay, this is the real depth, because now this image works as the object for the surface RS. Okay, so how much this distance? So from here to here d1, so it will be equal to d1. Okay, d1 plus t. Okay, so this is the real depth d1, this from here to here d1, and d1 plus t. So this is the real depth. Okay, now let us consider, so this is the real depth. So real depth is in this case, the real depth is how much? d1 plus t, and d1 plus t means mu x plus t, mu x plus t. Okay, now how much will be the apparent depth? Let's assume that apparent depth is d1 dash in this case. Okay, now apply the formula. So d1 dash divided by real depth is equal to refractive index of rarer medium is 1 divided by refractive index of denser medium is mu. So from here you will get d1 dash. So d1 dash is equal to dr divided by mu. Okay. Now dr is how much? Dr is how much? Dr is equal to mu x plus t. So mu x plus t divided by mu. So from here I will get d1 dash is equal to x plus t by mu. Okay. Now this is the apparent depth d1 dash. This is the apparent depth from the surface RS. Okay, so let's draw the ray diagram first for this. So let's see, this is a normal at this point. Now here the ray is going from denser medium to rarer medium. So when it goes from denser medium to rarer medium, it moves away from the normal. Okay, it moves away from the normal like this. It moves away from the normal. Okay, done. Now if I extend it in a backward direction, you can see, if I extend it in a backward direction, I'll get the image here. This is I2. This is my image I2. Now distance of I2 here, distance of I2 from this surface RS is how much? How much we use? D1 dash. Okay. So it is how much? D1 dash. D1 dash. Okay. I hope you all understand. Now this is the refraction through a glass slab. Now let's find out the shift. How much will be the shift? Okay, so shift S. So shift S is equal to, so you can see this distance of this object O from this surface RS. It will be how much? This X plus T. Okay, distance of O object from RS is how much? This X here to here. This distance is X plus T. So X plus T. Okay, so X plus T, then minus distance of final image means I2, distance of final image I2 from this surface RS is how much? D1 dash. So D1 dash. Okay, so we will get X plus T minus, now D1 dash is how much? D1 dash is X plus T by mu. So D1 dash is X plus T, X plus T divided by mu. Okay, so solve this. X plus T minus X minus T by mu. So cancel out this X to X. You will get T minus T by mu. Okay, finally you get the shift T 1 minus 1 upon mu. Okay, so this is the shift by the, when the refraction take place through a glass slab, this is the shift. Okay, so what is the important to derive this equation for the shift? It is important to know when to consider the object is in a rarer medium and when the object is in a denser medium, also how to apply the formula. So you can see in the first case the incident ray is in a rarer medium, so I consider that the object is in a rarer medium. So when the object is in a rarer medium, this is the formula for apparent depth, dA by dr. dA divided by dr is equal to mu d by mu r. Mu d means refractive index of denser medium, mu r is refractive index of rarer medium. Okay. Now this is the image formed by the first surface PQ, then the image formed by the second surface RS, which is the final image. So for this surface RS, this red line is a incident ray, and this is in a denser medium. Okay, this ray is in a denser medium. So I apply the formula here for the denser medium. So for the denser medium, the apparent depth formula is dA by dr is equal to mu r by mu d. Okay. So this is the way to derive the equation for the shift when the refraction take place through a glass slab. Okay. So I hope you all understand the uh, this explanation or the derivation of this formula. Okay, thank you.